Hi everyone, today we are going to be modeling polynomial functions. So, in the first example it says to write the cubic function whose graph is shown to the right. Whoa, R-I-G-H-T. Now, I need to look at this graph to figure out what I have. Well, I have 3 x-intercepts, and I know that since this is cubic, that's the most I can have. So I can write these actually in factored form. So I'm going to start with my factors. So I'm going to say f of x equals. Now, since I have -3, the factor would be x plus 3. And I'd have x minus 2 and x minus 5. Okay, because I know that ultimately, since these are the x-intercepts, I'd be able to write it in factored form. What I don't know is if there's any coefficient in front. So I'm going to label that A. The other piece of information that I have is this other random point on here that I'm going to call xy. Okay, right, all ordered pairs are in the form xy, but these are x-intercepts, so I use them for my factors. And now I'm going to use this point to help me solve for A, because when I'm done, I need a number there. Okay, it's ultimately going to look just like this, but I need to figure out what A is equal to. So x is 0 and y is -15. So that's going to give me -15 equals A times 0 plus 3, 0 minus 2, and 0 minus 5. So for every x, I plugged in 0, and for y, I substituted in -15. Then I'm just going to solve for a. So that is -15 equals a times 3 times -2 times -5. So that calculates to positive 30. And I need to still solve for a. So since I'm multiplying this together, I'm going to divide both sides by 30. So I get a is equal to -1/2. Okay, so now I'm going to substitute that back into my original function so I can create the cubic function. Okay, so a is -1/2. I have x plus 3, x minus 2, and x minus 5. Okay, and it's important that you write it in this format. Sometimes people want to say, but don't I need to plug this point in here? And I want to say no. Because if I ask you to graph this, I want to know for every x, right? X can be anything and y can be anything. So we want to make sure that we're writing it as a general form. Okay, so now use finite differences to determine the degree of the polynomial that will fit the data. Okay, so finite differences are the difference between the y values. Okay, these are y values, right, f of x, and I need to find the difference between all of them. So I'm going to walk you through this example, and then we'll do another one, and it'll make sense after that. So between -4 and 0, I'm going up 4. Right, to get from -4 to 0 on a number line, I would have to add 4. Then to get from 0 to 10, I'd have to add 10. From 10 to 26, I'd have to add 16. Right, I'm just thinking about this on a number line. To go from 10 to 26, I need to add 16. To go from 26 to 48, I'd have to add 22. Okay, and if you need to use your calculator, you would say, okay, 48 minus 26 is, whoop, not even working, 22. So just make sure that you're checking things properly. So from 48 to 76 is 28. So that's my first row. Okay, and I need to figure out what row I'm going to end at, and I'll show you that in 1 minute. So to go from, we got a second row. So to go from 4 to 10, I had to add 6. To go from 10 to 16, I had to add 6. To go from 16 to 22, I had to add 6. And to go from 22 to 28, I had to add 6. So this is row 2. What you're looking for is to have all of the y's evenly spaced, because all of the x's are evenly spaced, like 1, 2, 3, 4, 5. And now these are all the same. Okay, we want them to be all the same. So the second level means that we're going to use a quadratic. right? That's degree 2. If you were at the 3rd level, you would use a cubic function. If you were at the 4th level, you use a Cortech function. So we'll use another example to help us with that. But what I need to do now is use my graphing calculator to find the polynomial that fits the data. So I did the finite differences, right? You're looking for the differences, you're looking for the line where they're all the same. So we decided this is quadratic. So I have to use this function in my calculator called Quadraeg, okay? So right now I need you to take out your calculator. Let me resize this so you can see it. That I need to go to Stat, Edit, and I'm going to enter my data into L1 and L2. So Stat, Edit, and you need to do L1 and L2. And L1 is your x's and L2 are your y values. So 1 through 6 are going to go in L1. So 1, 2, 3, 4, 5, 6. And at this point in the video, you really should be following along in your calculator. Okay, and then I need to put all the y values in L2. So that was -4, 0, 10, 26, 48, and 76. So once I do that, I'm going to go to second quit, I'm going to go to my home screen, and now I have to do the quadratic regression, okay? And that would be stat calc, and then you're going to choose quadratic regression. So you go to stat, over to calc to the right, and quadratic regression is number 5. You might use linear, cubic, or Cortech at any point during this lesson, but since we were at that 2nd level, we're using quadratic regression. So number 5. Okay, so I have an older calculator on here. So if you have an older calculator, you're just going to press enter right now. If you have a newer calculator, you're going to need to go down to where it says calculate, maybe right here, and then you're going to hit enter. So a quadratic equation is in the form ax squared plus bx plus c, right? We know that that's the standard form for a quadratic equation. And a is going to be 3, b is going to be -5, and c is going to be -2. So my polynomial will be 3x squared minus 5x minus 2. Okay, so predict the value of f of x when x equals 10. Okay, so f of 10, I just need to substitute in 10 here. So 3 times 10 squared minus 5 times 10 minus 2. So that gives me 248. So once we have a polynomial that we can model the data with, we can make predictions. Okay, let's do one more. So we're going to use finite differences to determine the degree of the polynomial function that will fit the data. Okay, so to go from, now I'm going from positive down to a -4. So to go from 26 to -4, I'd have to subtract 30. Okay, to go from -4 to -2, I'd have to add 2, right? Because -4 plus 2 is -2. To go from -2 to +2, I'd have to add 4. To go from 2 to 2, I'd add 0. And then from 2 to 16, I would add 14. Okay, so that's row 1. So it's very important that you're checking your computations. You need to get these right, otherwise it's not going to work. Okay, so to go from -30 to +2, I'd have to add 32, right? Because -30 plus 32 is 2. To go from 2 to 4, I would add 2. To go from 4 to 0, I'd have to subtract 4. Okay, anytime you're decreasing in value, you have to subtract, right? Because 4 minus 4 is 0. And then from 0 to 14, I'd have to add 14. Okay, now to go from that's my second row, but they're not the same yet, so I need to keep going. Okay, so to go from 32 to 2, I have to subtract 30. Then to go from 2 to -4, I'd have to subtract 6. And again, 2 minus 6 is negative 4. And then to go from negative 4 to 14, I'd have to add 18. So that's row 3. So this would be linear, quadratic, cubic, but they're not the same yet, so I'm going to try one more time, and let's hope that I get something here. Okay, to go from negative 30 to negative 6, I'd have to add 24. Right, negative 30 plus 24 is negative 6. Then how do I get from negative 6 to 18? I have to add 24. So since these are the same, I get to be done with row 4. So this is degree 4, which is a quartic function. Okay, and that's because on the 4th row, I had the same value. So then we need to use the graphing calculator to find the polynomial that fits the data. So we're going to do this the exact same way. We're going to go to Stat and Edit and put in our new table. So luckily for us, our x values are the same. I just have to change the y values. So 26, negative 4, negative 2, 2, 2, and 16. Okay, so this time, when I quit, I'm going to go to Stat to the right to Calc, and I'm going to choose Cortech Regression because I have a Cortech function. So that's number 7. And you press Enter, or you go down to Calculate and press Enter. And here are your values. So you have ax to the 4th, bx to the 3rd. It's going to go cx squared, d, and then e. So these numbers go in order. So we use the numbers for our calculator. A was 1, so that was just x to the 4th. And then b was negative 15, x to the 3rd. C is 81. Then I've got negative 183 and 142. So 81x squared minus 183x plus 142. Okay, so again, this video is all about finite differences and using your calculator to model data, as well as example number 1. So if you have any questions, make sure you write them down. But make sure you watch this video if you need to see the example again. Make sure you know how to do this on your calculator. See you later.